This video is about implementation of a simple blockchain with Python. In this video I will move slowly by steps. And first of all I want to create a new blockchain folder. And inside the blockchain folder I want to create a file and I want to name it just one. And in this file I'm creating a new JSON object. Let's say my blockchain will represent lending money contracts. So the block will contain a data about the borrower. For example, the borrower is Jack. The lender. Amount of the loan, 1,000 for example. And I want to focus your attention that in JSON we have to use double quotes for strings. Then I want to store data about the previous block. I think that I need its hash and the file name. Let's add a new key. It'll be prev block, for example, and it will be a dictionary, a JavaScript object with two keys. It will have the hash key that will be an empty string for a while, and the file name that will be an empty string too, because it's the first and the only block, and that's why I'm creating it manually. Now I'm going to the upper level and creating here the blockpy module. In the blockpy file, I'm creating an entry point of the script. It's the if main block. And the if name block checks whether the file was run itself or was imported. If the file was run, this condition will return true and the main function will be called. I'm defining the main function. Then I need two functions. The first one will create blocks with my data, and the second one will check the integrity of the entire chain. So let's define a new function, WriteBlock function, and in the body of the WriteBlock function I want to create a dictionary with the data that should be written in a block. The data, a dictionary with the same keys. Just copy it here. I want to define it manually for a while. Later I will replace the values of the keys with the variables. Now I have to serialize my data dictionary to a JSON object, and to do it I have to import the JSON module. Import JSON. Also, I want to write the data dictionary to a file. When we are working with files, it's better to use the with context manager because it will close the file object after data will be written into it. So, with then I call the open function and I have to pass into it the name of the file I want to open. If the file exists, the open function will open it. If the file does not exist, the open function will create it. Let's say the file will be the test for a while, and I open it for writing and save the open file object to the f variable. Now I have to write the data dictionary to the file as a JSON object. So I have to use the JSON module, and I'm calling its dump method. As the first argument, it takes the data I want to write. It's the data dictionary. The second argument is where I want to save it. It's the file object opened for writing. It's the f variable. Then I want to have indentation. Indent will be 4. And for Unicode characters, ensure ASCII parameter should be false. And also I want to add a new empty line in the file, write \n, because in Unix systems files should end with a new line. Now I want to call the WriteBlock function from the main function. And let's test it. It works. I've got the test file with this structure, with this block information. Okay, let's delete it. Now I need to refactor my code a bit. First of all, I want to replace the change in data with variables. I mean, the values of the keys of the data. And the path to the file should be blockchain and then file name. So in the WriteBlock function, in its definition, I want to add its parameters. It'll be borrower, lender, and the amount. And when we call the WriteBlock function and pass into it some arguments, these parameters will become local variables, and we can use them in the body of the function. And so the borrower key of the data dictionary gets the value of the borrower variable, the lender, and the amount. And in the main function, I want to pass into the WriteBlock function some data. Let's say the borrower will be Andrew, lender will be Kate, amount 100. And also I want to store all block files in the blockchain directory. And so I have to determine the name of the next block instead of the test. So let's create a current block variable. Current block is the file name of the block. Blockchain folder, and then I have to determine the file name itself. And to get the file name for the current block, I want to get the length of a list of the files in the blockchain directory and increment it by 1, because I want to use integers for my blocks. So to do it, I have to import the os module. Import os. Here I'm calling the os listdir function and define here the name of the folder, blockchain. The ListViewer function will return a list of files and directories in the blockchain folder. So I want to get its length. I have only one file, so the len function will return 1, and the current block will be 2, number 2. So I have to increment it by 1, and as I use here the concatenation, I have to convert this expression to string. Otherwise I will get an exception that I cannot concatenate a string and an integer. And then I have to use the current block variable here in the open function. Let's test it. I run the script and I've got the second block in the blockchain directory, and the second block has the file name 2. We can delete it because it doesn't contain the hash and the file name of the previous block. The next step is to get the hash and the file name of the previous block in the blockchain directory. Let's import the hashlib library. And let's define a new function. Let's name it GetHash function that takes a file name of the previous block as an argument. Previous block. Here, first of all, I have to read the file with the prev block file name. And of course, this file is stored in the blockchain directory. So with open blockchain plus the file name prev_block variable, and I'm opening it for reading binary RB and save it to the f variable. The content will be f_read. And the GetHash function will return the MD5 hash of the content variable, the content of the previous block. Hashlib, I'm calling the MD5, as I did in the second video, the content as an argument, and I'm calling the hex digest method. And as you can probably notice, I have encountered the problem of a code redundancy. The name of the blockchain folder is hard-coded in two functions already, here and here. And I think it's better to create a global variable. For it, blockchain dir equals to blockchain slash. Then I want to use the blockchain dir variable here and here instead of the string, and also here. And now in the WriteBlock function I have to call the GetHash function and pass into it the name of the previous block. As I choose to use integers for the file names, I can use just the length of the file's list that I got with the listdir function to determine the file name of the previous block. So I have here only one block, so if I get the length of the file, I will get the name of the previous block, the first one. And so in the WriteBlock function, I'm creating a new blocks count variable somewhere at the beginning. Blocks count. It will be the length of the listdir list, and I'm passing the blockchain dir here. Then I want to define the prev block variable, and will be just converted to string the blocks count variable. And the current block variable gets the following value: blocks count +1. And accordingly, the hash key of the previous block dictionary in the data dictionary, the returning value of the GetHash function, and I'm passing into it the prev_block variable, and the file name gets just prev_block. Let's test it. I have the second block, and now I have the hash of the previous block and the file name of the previous block, the one. It's a string. Okay, it's working. Now I want to create more blocks. I need 11 or maybe 12. And I want to be able to check the integrity of my blocks. I want to define a new function somewhere here. Let's name it check integrity. And here I have to get the list of files in the blockchain directory again. Then I have to get the values of the hash and the file name keys of each block, of each file. And I want to start from the second block because the first block has no this data. And also I have to calculate again the hash of the previous block and then compare the values. I'm creating the files variable. I'm calling the listdir function and passing into it the blockchain dir variable. Let's print it. Print files. In the main function, I comment the call of the WriteBlock and call check integrity function. Let's run the script. And we can see the list of files, but it's unordered list of files. So I want to use the sorted function to sort the list of files. Sorted. Let's run it again. And we can see how the sorted function sorts our list of integers. 1, 10, 11, 12, then 2, 3, 4, etc. And as you can probably know, the sorted function can take also the key argument. The key. And this key argument determines a sorting criteria. And in this case, all file names should be integers. So I have to convert the file names to integer data type. So the key parameter will be just a simple lambda function that takes only one argument, x, and will return converted to integer the x variable. Let's run the code again, and we can see properly sorted list, 1, 2, 3, etc. Okay, now I want to read the hash of the previous block for all files except the first one. To do it, I need to use a for loop. For file in files, and to get all files except the first one, I want to use slicing. So I need all files from the index 1. The first index is the element number 2, 0, 1, and until the end. This place is empty. In the body of the for loop, I want to read this JSON object. To do it, first of all, I have to read the file and then pass its content into the JSON load function. So again, with open blockchain dir plus file, the file variable, save it to the f variable, and the block variable will be JSON load f. The load function will return a dictionary, and now the block variable is a dictionary. Now let's define the prev hash variable and prev file name variable. So the prev hash is the block dictionary, and I need its prev block key. I call the get method prev block key, and it's a dictionary too, so I call the get method again and pass into it the hash key. The same for the file name, except the key. It's the file name. File name. Let's print the prev hash variable. And we can see the hashes of all blocks. Okay. And now I want to compare the hash that has been written in the block, it's the prev hash variable, with the actual hash of the previous block. So I need to calculate the actual hash of the previous block. Actual hash equals to get hash, and I am passing into it the file name of the previous block, prev file name. Now let's compare the hash that has been written in the block, prev hash, with the actual hash of that block. The rest variable will be OK, otherwise the rest variable will be was changed. And let's print the f string, something like this. Let's run the code, and we can see that everything is OK. Now I want to change something. For example, the second block, I want to add a 0, save, and run the code again. And we can see that block 2 was changed. Okay, let's return it to the original state. And everything is alright again. It works. And the last thing I want to do, I want to have a list that will append with the results of checking process. Let's create outside the for loop, before the for loop, a new variable, the results. For example, it will be an empty list for a while, and on each iteration of the for loop, I want to append the results list with a dictionary. Somewhere here, results append, and it will be a dictionary where the block key will be priv file name, and the result will be res, and the check integrity function will return this results list. Return results. In the next video, I'll wrap the script with the Flask app. If you like the video, please leave a like and subscribe to the channel. Thanks for watching.